Welcome to section 6.2, inverse function and relation. So, before we go into solving and finding inverse function algebraically, let's review the 4 basic rules on how to find inverse function. So step 1 is convert f of x into y. Step 2, you switch x and y in their places. Step 3, you solve for y, meaning that you get y by itself. And then step 4, convert y into f to -1 of x. Now, even though step 1 and step 4 we have f of x and f -1 of x, this process can still be applied if we're using other letters like h of x, m of x, p of x. So again, it's the same process, it's just usually you're going to be using the variables x and y. So again, make sure you have this in your notes, make sure you remember this when finding inverse function algebraically. In our first example, we have f of x equals 3x minus 7. So I'm going to follow these 4 steps. Next, first, I'm going to convert f of x into y. So we're going to have y equal 3x minus 7. Step 2 is to switch x and y in their places. So I'm going to have x equal 3y minus 7. After that, if I want to get 3y by itself when I'm working on step 3, I need to get rid of my minus 7. So I'm going to add 7 to both sides. So on my left, I'm going to have x plus 7 equal to 3y. Alright, then I'm going to move it over here for more space. But I'm going to have 3y on the left, so I'm going to flip the whole thing. So in order to get y by itself, I'm going to divide both sides by 3. So I'm going to have y equal x plus 7, the whole thing divided by 3. Now, since I have multiple parts in the numerator and a single number in the denominator, I'm going to check if I can split this into multiple fractions. I have nothing in common between 1x and 3, and I have nothing in common between 7 and 3. So in that case, I'm going to leave it as one big fraction. I'm not going to split it because I have nothing in common from the numerator and denominator. And then the last step, convert y into f of -1 of x. So f -1 of x is equal to x plus 7 over 3. And that would be my final answer when finding algebraically the inverse function. In our next example, we have f of x equals 6 minus 5 over 2x. So, following these 4 steps, step 1, convert f of x into y. So I'm going to have y equal 6 minus 2 over 5x. Next is to switch x and y in their places. So I'm going to have x equal 6 minus 2 over 5 y. Now from there, we're in step 3, solve for y. So in order to get -2y, 2 over 5y by itself, I have to cancel out the 6. So I'm going to subtract 6 on both sides. So on my left, I'm going to have x minus 6 equal to -2 over 5y. Now from there, since I have a fraction in front of the y, so what I'm going to do is I'm going to multiply both sides by the denominator so that I don't have a fraction anymore. In addition, since this fraction is negative, I'm going to multiply both sides by the negative denominator. So on my right, I'm going to multiply by negative 5. Now on the left, since I actually have two terms, my x and my minus 6, I'm going to put this in parentheses, and then I'm going to multiply the whole thing by negative 5. Now on my right side, when I'm multiplying negative 5 to the fraction, the number will divide the denominator into 1, and I'm going to have what's left 2y. And then on my left, I'm going to distribute the negative 5 to everything inside. So I'm going to have negative 5x plus 30. After that, I'm going to divide both sides by 2. Now, I'm going to have the y on the left side, so I'm going to flip the whole thing. So I'm going to write over here for more space. So I'm going to have y equal negative 5x plus 30 over 2. Now, let's take a closer look at the fraction here. See if we could split it into two fractions. Now, I have to check, is there anything in common between negative 5x and 2? Which there is, and there is not. But is there something in common between 30 and 2? Yes, there is, because both of them are even numbers, divisible by 2. So I'm going to write it as two fractions instead of one. So here, I'm going to write y equals negative 5/2 x plus 30 over 2. Now again, the only time I can split this into two fractions or multiple fractions is when you have a single denominator. Now the only thing I can simplify is the 30 over 2. So what I'm going to have is y equal negative 5/2 x plus 30 over 2. That was going to be plus 15. So once I finish simplifying that, next is step 4. Because I finished solving for y, I'm going to convert y into f of negative 1 of x. So it's going to be f to negative 1 of x equal negative 5 over 2 x plus 15. And that would be my final answer on finding inverse function algebraically. So there's our final answer. In this third example, we have m of x equal 4x minus 1 divided by 3. So let's do step 1. Convert f of x into y. So in this case, we're going to convert m of x into y. So it's going to be y equal 4x minus 1 over 3. After that, you're going to switch the x and y in their places. So when I switch them, I'm going to have x equal 4y minus 1 divided by 3. Alright, now to start off solving for y in step 3, we need to get 4y by itself. Now take a closer look at this. So see how 4y minus 1 is over 3. So it's the big fraction. What's different with the last example is that the 6 was not part of the fraction, so we had to get rid of this one first. The 4y and the minus 1 is part of the fraction, so we need to get rid of the denominator. So in order to do that, I'm going to multiply both sides by the denominator. Now, on the right side here, when I multiply the fraction by its denominator as a whole number, the whole number in the denominator will divide into 1, and I'm only left with 4y minus 1, and on the left side it will be 3x. Now to get 4y by itself, I'm going to cancel out the minus 1, so I'm going to add 1 to both sides. So 3x plus 1 equal to 4y. Alright, I'm going to bring this over here for more space, but what I'm going to do is I'm going to flip the whole equation where y is on the left side. So 4y equal to 3x plus 1. Now, to solve for y, I'm going to divide both sides by 4. Now, you could do this, the whole thing, or you could do it separately. So divide this by 4, divide this by 4. So what you're going to have is y is equal to 3x over 4 plus 1/4. 3x over 4 is the same thing as 3/4 x. Doesn't matter which form you use as long as you write it correctly or do the work correctly. Now, since I cannot simplify each fraction and they both have the same denominator, you can actually leave it as a combined fraction. So it will be y equal to 3x plus 1, the whole thing divided by 4. Now, once you see that there's nothing you can simplify with a fraction, you're pretty much done with step 3, getting y by itself. Step 4, convert y into f to negative 1 of x. So in this case, since we started with m of x, we're going to have m to negative 1 of x equal 3x plus 1 over 4. And this is the inverse function after being solved algebraically. So here's our final answer.